It is important to maintain the quality of the products. This research presentation is based on the assessment of the state of quality in garments applying data mining mechanisms, a case study in the apparel industry. You can cite the full paper in the conference proceedings of 11th International Conference on Business and Information 2020. Quality for the textile industry, that is a measurement concerning the acceptable level of materials. This research is based on a famous garment factory which provide famous brands across the world. And this is a manufacturing plant that produce the products like thongs, briefs, boxes and camisoles. The quality of the final good is measured using the first time through state or the FTT state for the selected top brand. Simply, FTT is a measure of production efficiency, ability, quality and skill. The equation for the FTT percentage indicates it is based on the daily production and the number of reworks per day. The factory capacity is to maintain the FTT as 98% or above as the category of high state. For the low state category, it considered the daily FTT percentage less than the 98%. This is the workflow of the garment factory. It consists of 30 lines, and in a line there are two teams as A and B. For a team there are 12 machine operators with a quality checker. The two teams in a line A and B are separated by a checking board. The dependent variable is the daily FTT state. Independent variables are team, garment type, operation, types of rework or the damage type, number of damages and the daily production. There are 51 types of damages that is listed down in the defect type sign document. Every quality checker in a team maintains a document known as inline rework report. For a particular operation activity in the style, each damage type is marked with a coded letter by the quality checker. At the end of the day, quality checker calculates the FTT state, which is high or low according to the production and the number of damages. The purpose of the study is to build suitable models using data mining methods for the classification problem, then to identify a better perform model to forecast the states of the first time through. Moving on to the significance of the study. This study will add more value to the existing knowledge. Also, the application of data mining techniques rather than relying on the traditional statistical techniques. In the perspective of the garment, we can identify the optimum allocation of a team to a style that is the garment type of the top brand to achieve the highest FTT state. Also to recognize the training requirements of the employees for a low state category. Furthermore, to improve the satisfaction of the customer by improving the state of quality in garments. Past work related to this study is mainly discussed under 5 categories. They are productivity, quality, garment defects, first pass yield, and data mining. Under the quality category, the previous researchers have found at which resources they should maintain the quality, and also they evaluate the quality of the products using bar charts, histograms and different models like analysis of variance regression. To measure the productivity, the previous researchers have applied the root cause analysis, factor fixed and random effects model, simple random sampling and work measurement techniques. To identify the garment defects, mostly the researchers have applied the descriptive analysis, also the generalized linear model and the methodology of Six Sigma of DMAIC. There were no studies related to the first time through. However, a similar idea was illustrated by the first pass seal. There were two studies related to this technique, and they have used the DMAIC and descriptive analysis and Pareto analysis and cause and effect diagrams in their methodologies. Moving to the data mining part, the different data mining techniques have applied in the manufacturing. They are probabilistic neural network, artificial neural network, decision trees, and many others. Methodology. Data were collected for the initial 3 months in 2019 from the online rework reports maintained by the quality checkers. Randomly selected 80% of the data was applied for the training and the remaining 20% for the testing. As the initial step, descriptive analysis and cross-tabulations were conducted. Then the association tests. Moving on to the data mining approaches, two techniques were applied. They are classification tree and the probabilistic neural network. Classification tree is a type of decision tree. In here, the best attribute is identified using the top-down induction algorithm. Predict the values of the categorical dependent variable, and in this research it is the daily FTT state. Gini impurity measure is used to identify how well the classes are separable. The confusion matrix was built to identify the performance measurements. They are FP rate, TP rate, accuracy, recall, precision, and F measure. The class imbalance problem was addressed by the undersampling technique. Probabilistic neural network has the same idea of the classification tree. However, its network architecture is different and it has an input layer, pattern layer, summation layer, and output layer. The confusion matrix is used to identify the performance measurements, and the class imbalance problems was addressed. The findings indicate from the figure 1 that the majority of the data belong to the high state category. That's why we are going to address the problem of class imbalance. Figure 2 indicates the bar chart of the garment types, and it indicates that the thong garment type has the highest count. By the cross-tabulation, the high FTT state indicates that the highest number of damages is from the high-low damage type. For the low FTT state, it's from the measurement out damage type. There were associations between the categorical variables, which are operating activities, garment types, and the damage types. The Pearson correlation coefficient indicates that there is no strong relationship between the variables. In the built classification tree, the root node was the number of reworks, and in the next level, the attribute was the daily production. In later splitting, the attributes, type of damages, garment types, and operation activities were applied. An important factor was that the input variable t was not in the built decision tree. Through the confusion matrix, it indicates that there are 7 and 5 misclassifications, and there are 972 and 216 of correct classifications. However, with the majority of data belongs to the high state category, it indicates the class imbalance problem. With the application of the undersampling technique, the total number of observations have reduced to the 2,321 data points. However, still the root node has the same attribute as the number of damages. In the next level, it is the daily production in the built classification tree. An important factor in here too, the variable t is not in the built tree. The confusion matrix indicated that there are only 11 misclassifications, and there are 210 and 243 correct classifications which are equal. Now it indicates that the class imbalance problem has reduced. The probabilistic neural network model was built adjusting the spread parameter from 0 to 1. In here, the favorable spread parameter was zero point 0.9 by the true positive, true negative, false positive and false negative values. Figure 3 indicates the PNN model. With the application of the undersampling technique, the favorable spread value is 0.8. The figure 4 indicates the probabilistic neural network model after the application of the undersampling technique, and in here for the training set there are 1857 observations. Discussion and recommendation. There were two major defects that were found by the cross-tabulations, and they are high-low and measurement out damages type. There are different reasons for occurring of these damages. Some of them are unbalanced sign, failure in the machines, nature of the fabric, incorrect patterns, and cutting problems. The entire quality is affected due to these damage types, and it is very much important to get the remedies to avoid them in the future. Moving on to the next, there is no effect from the variable t for the daily FTT state. It may due to the variable t may represent all the other independent variables. As the equation of the daily FTT state represents, there is a direct impact from the number of reworks and the daily production for the daily FTT. And it's also confirmed by the nodes of the classification tree. Final results are indicated in this table 6. It indicates the performance measurements of the classification tree and the probabilistic neural network before undersampling and after the undersampling. The favorable performance measurements values are given by the classification tree with the undersampling technique. However, all the results indicated that they have a higher TP rate, precision, recall, accuracy, F-measure, and a lower FP rate. Limitations of the study. The data were not available for all the brands in the factory, and there may be some other factors affecting the daily FTT state. And these FTT state values are depending on the eye inspection of the quality checker. For further improvements, can apply the other data mining techniques and also can consider the extra factors like standard mean value, hourly targets, and daily targets. Finally, the conclusions. The better perform model to predict the state of quality of the garment is the classification tree with the undersampling technique. However, both the models discussed under the undersampling technique, which are classification tree and the PNN, can be used in prediction. Even though the classification tree and the PNN model with the class imbalance problem had a high accuracy, the new data can predict the wrong state of daily FTT.